Hello my dear learners, today we will start a very new topic in antenna and wave propagation, and that can be named as radio wave propagation. In this particular subject, the importance and existence of radio wave propagation is very critical, because this is a part of this subject when we deal the phenomena, the mechanism which is within the free space. When the electromagnetic signals are propagating through free space, the complete mechanism from the transmitting end to the receiving end is known as the wave propagation phenomena. And especially in this lecture, we will dedicate our complete focus on the basics of radio wave propagation and how the different antennas are propagating radio waves, and how these radio waves, by how many means these radio waves are propagating and reaching to the destination. So, this complete mechanism comes into the category of radio wave propagation, and we are starting today's lecture as the introduction of radio wave propagation. So, starting with the introductory part of radio wave propagation, as you all know that when a communication link is established between a transmitter and a receiver, between a source to destination, between the transmitting antenna to the receiving antenna, this complete link is dedicated to the behavior of the atmosphere and the different kind of electromagnetic waves in the atmosphere show the different characteristics during the propagation from transmitting end to the receiving end. So, when we define this particular mechanism in the atmosphere, we can say that radio propagation is the behavior of radio waves as they travel or are propagated from one point to another or into different various parts of the atmosphere. The different kind of different modes of propagation works in the atmosphere for traveling a transmitting signal to the receiving signal. Means the transmitter, when it sends the transmitted signals into the atmosphere, and at the other end, when at the receiving point, when the receiving antenna is receiving or extracting the information in the form of electromagnetic signal from the atmosphere, this behavior of the electromagnetic signal is studied in this topic of radio wave propagation. As a form of electromagnetic radiation like light waves, radio waves are affected by the phenomena of reflection, refraction, diffraction, absorption, polarization and scattering. These all phenomena are studied in this radio wave propagation, because as I have already discussed that different kind of electromagnetic waves, the frequency wise different behavior of these electromagnetic wave provide such kind of different mechanism or phenomena, or when a light waves are travelling in free space, it is going through the different process of reflection, refraction, absorption, scattering, diffraction and many other phenomena. So, we will study the radio wave propagation also into these mechanism and different kind of processes. Electromagnetic waves are generated by the radiated power from the current carrying conductors, and in conductors a part of generated power escapes and propagates into free space in the form of electromagnetic waves, as we have already studied this particular part in the electromagnetic field theory. How a current carrying conductor is capable to produce the electromagnetic waves in the atmosphere, and all these electromagnetic waves are showing the radio wave propagation behavior in the atmosphere. These are radiated from an isotropic transmitter and travel through different paths to reach the receiver. Generally, we expect that the transmitter should be an isotropic radiator, but it is a hypothetical approach because no any practical antenna can be an ideal isotropic radiator. So, the tendency of any kind of transmitting antenna is to be like an isotropic radiator. So, simply we think that an isotropic radiator is spreading its all the radiated power in all the directions. So, the tendency of any transmitting antenna should be like that only. The path taken by the wave to travel from the transmitter and to reach the receiver is known as the radio wave propagation phenomena. Now, we will study the different modes of propagation. There are basically three modes of propagation generally in its standard and its most simplified way. So, the wave propagation of electromagnetic waves in the atmosphere and in free space may be divided into the following three categories, and these are given as ground wave propagation, sky wave propagation, and third one is the line of sight propagation, which is also known as the space wave propagation. As ground wave propagation is also known as surface wave propagation, sky wave propagation is also known as the ionospheric propagation, and this space wave propagation is known as line of sight propagation. In this slide there are two diagrams which shows the basic kinds of modes of propagation. As you see in this particular diagram, what it shows that this is the earth and this is the curvature of earth, and when the curved earth is having two antennas at the transmitting end at the receiving end, then three modes of propagation can be shown within the transmitting and receiving antenna like this. The first one, this one is known as the direct waves, when the simply this is known as the direct wave and this is known as the indirect wave. It means from the transmitting antenna to the receiving antenna, electromagnetic signals are directly reaching to the destination, but in this path the electromagnetic signals are reflected from the earth's surface and after that they are reaching to the destination. So, this phenomena, when this kind of electromagnetic signal path propagation is taken place, it is called as the space wave propagation. When the electromagnetic waves are taking the path of surface of the earth like that, you can see here that here as shown in the dotted lines, these dotted lines are showing the behavior of surface waves. They are also known as the ground waves. These are known as ground waves or surface waves because they are in the complete effect of earth surface or ground surface. That is why they are known as the surface waves or ground waves, because they are taking the path as the curvature of the earth is following. So, in this way this particular path is known as the surface wave or ground wave propagation. This is a very special kind of mode of propagation which is known as sky wave propagation. This mode of propagation is through the ionospheric layer, which is situated at a distance of 40 kilometer to 50 kilometer to 400 kilometer, and by using the different layers, different regions of the atmosphere within the ionospheric region, this particular range of the distance in the atmosphere is dedicated to the sky wave propagation or ionospheric propagation. This sky wave propagation is dedicated to a very specific layer of the atmosphere which is known as ionospheric layer, and this ionospheric layer is, as I have told you, it is between the 50 kilometer to 400 kilometer, and when the electromagnetic signals from the transmitting antennas are reaching to the ionospheric region and they are moving through this ionospheric layer and reflecting back to the earth, to the receiving point, this phenomena is known as the sky wave propagation. So, this is a very special kind of mode of propagation, very special and a very scientific approach. What's after these three modes of propagation? This particular range is given for this. It is known as the satellite communication. It means when we want to carry more higher frequencies through the communication, through the atmosphere, through the free space, we have to adopt a very special kind of mode of propagation which is known as the satellite communication. And this satellite communication is a very specific subject in the field of communication engineering. So, we will study the different ideologies and the different terminologies which are used in the satellite communication, but here we can say that satellite communication is also a very specific extended kind of mode of propagation in the radio wave propagation subject. Some of the theory is given related to the modes of propagation. At lower frequencies in the MF, LF and VLF bands, diffraction allows radio waves to bend over hills and other obstacles and travel beyond the horizon, following the contour of the earth. Simply, when we follow these three modes of propagation, definitely they are based on the frequency range classifications. Ground wave or sky wave propagation is based on the lowest frequency range, which is occupied only in the band of LF and VLF simply. And if we talk about the highest range of ground wave or surface wave propagation, it is only up to 2 megahertz. And simply we can say the ground wave or surface wave propagation is limited to this lower frequency range only up to 2 megahertz. So, we have to adopt other modes of propagation for the higher frequency range in communication. These are called surface waves or ground wave propagation. AM broadcast and amateur radio stations use ground waves to cover their listening areas. As I have told that 2 megahertz is the highest frequency which can be utilized by the ground waves or surface wave, and it comes under the category of MF. Some of the medium frequency bands are utilizing the ground wave or surface wave propagation. So, simply the AM broadcast, especially AM broadcast is the application which can be utilized for this particular frequency range and by using the surface wave or ground wave propagation. VLF and ELF waves can penetrate simply significant distances through water and earth. As I have already discussed in my previous lectures that the ground wave or surface wave propagation is especially limited by the ground losses, and these ground losses are not so much effective in the water surface. So, when we talk about the communication on the water surface or sea surface, generally we utilize the surface wave or ground wave propagation in harbor telephony. When we talk about the communication between two ships, then the ground wave or surface wave propagation can be used for the higher frequencies, because in the water surface the losses are less comparable to the ground or earth surface. So, simply in these frequency ranges communication signals practically are very useful and can be utilized in the higher version. At medium waves or short wave frequencies MF and HF frequency bands, radio waves can refract from the ionosphere. This is the theory of ionospheric or sky wave propagation. When we talk about the frequency range from 2 megahertz to 30 megahertz, this is the range of MF and HF band. So, all the applications which are in the frequency range of MF and HF can utilize the mode of propagation known as sky wave propagation or ionospheric propagation. So, this mode of propagation is held in the layer of the atmosphere which is known as ionosphere, and ionosphere is situated within the height of 50 kilometer to 400 kilometer in the earth's atmosphere. It is used by amateur radio operators to communicate with operators in distant countries and by short waves broadcast stations to transmit internationally. There is a very important advantage of sky wave propagation which should be mentioned here, that the longest distance communication is possible by using the ionospheric mode of propagation. And it is simply just because of the fact that multiple reflections can be possible in the sky wave propagation or ionospheric propagation. We will study in very brief how it is possible, which is known as the multi-hop propagation. So, at last we say that sky wave propagation is the second form of mode of propagation. After that, space wave propagation is utilizing the higher frequencies in the electromagnetic spectrum, and when it utilizes the frequencies above 30 megahertz to more than 300 megahertz. What are the factors which are involved in radio wave propagation? Generally, the electromagnetic waves which travel from transmitter to receiver, there are many factors which influence this mechanism of radio wave propagation. They are known as the characteristic of the earth, such as conductivity, permittivity, permeability. These are the factors which affect the mode of propagation or the quality of propagation. Curvature of the earth, magnetic field of the earth, roughness of the earth, these are some other factors. Frequency of operation, it is a very important factor, because all the modes of propagations are limited to only few specific frequencies. Characteristic of ionospheric regions, distance between transmitter and receiver, refractive index and permittivity of the tropospheric and ionospheric regions. This is a simplified diagram of the structure of the atmosphere, how this structure of the atmosphere is reliable and very important in the radio wave propagation. You can say here that there are basic three layers in the atmosphere which are important from the communication point of view. They are troposphere, stratosphere and ionosphere. Troposphere is the region in which the maximum range of the distance is up to 20 kilometer only from the earth's surface. After that 20 to 50 kilometer, this is known as stratosphere, and 50 kilometer to 400 kilometer it is known as the ionosphere. This is the complete structure of the atmosphere, and we will discuss, we will divide the other layers of the atmosphere under the category of these three main layers of the atmosphere as troposphere, stratosphere and ionosphere. What are the characteristics of the different layers of the troposphere? We can say that the different points on the earth can be given for the different heights of the tropospheric region from the earth's surface, like from altitude, from the polar latitudes, from the poles, from the different places on the earth can be given for the different heights of the tropospheric region. So, overall we can say that the height between 10 kilometer to 20 kilometer it is known as the tropospheric region, but the height of the tropospheric region is slightly varying at the poles and the equators. As I told you, its height is least at the poles while maximum at the equators. You can understand the basic reason behind this. The gas components in the troposphere remain almost constant in the percentage with increase in height, but the water vapor density, water vapor components drastically decrease with the increment in the height. The significant property of the tropospheric region is the temperature decrease. It is a very important characteristic of the tropospheric region, where the as the height increases, the temperature is decreases very rapidly. The troposphere is also called region of change. At a certain height, it is called the critical height above troposphere, the temperature remains constant, and this region between the top of the troposphere and beginning of the stratosphere is called as tropopause. The different characteristics of the tropospheric region can be defined like this, as the minimum temperature in the tropospheric region comes as minus 52 degrees Celsius at its uppermost layer of the region. The different properties can be given, but some of the very important things which is known as the refractive index of the atmosphere within the tropospheric region. When it starts from the surface of the earth, it is slightly higher than unity, and when it reaches to exact unity, means refractive index of the atmosphere is equal to 1, it is known as the standard atmosphere. So, simply we will study about the refractive index phenomena of the troposphere as well as ionosphere, because this will play a very important role in the case of communication, in the case of mode of propagation. These are some of the characteristics of the stratosphere. You can understand, because it is consisting within the ozone layer, which is very important for all the living humans and all the living organisms. So, simply I have given a basic idea of the structure of the atmosphere, the different modes of propagation, and the overall picture of the radio wave propagation, how it is important in the case of antenna and wave propagation. So, thank you very much for watching my video. Thank you.